Differentiation between carbolic acid and acetic acid. This is today's lesson. In this lesson, we are going to learn how to differentiate carbolic acid and acetic acid. So let's get started. Differentiation between carbolic acid and acetic acid. First of all, let us see which one is stronger acid, carbolic acid or acetic acid. This is carbolic acid. Chemical name is hydroxybenzene or phenol, and this is acetic acid or ethanoic acid. Phenol. In water produces proton. Phenoxide ion and proton. Phenol in water yields proton, so it acts as acid, and its name is carbolic acid. This phenoxide ion undergoes resonance in this way, and ultimately we get resonance hybrid. Oxygen, carbon, oxygen, partial double bond, partially negatively charged. This is because this negative charge gets dispersed throughout the ion in this way. Ortho position becomes partially negative in charge. Para position becomes partially negative in charge. Ortho position gets partially negative in charge. That is, negative charge gets dispersed throughout the molecule, and in this way phenoxide ion stabilizes. That is, actually here phenoxide ion stabilizes in this way: partially negative in charge, carbon oxygen partial double bond, partial double bond, ortho position partially negative in charge, para position partially negative in charge, ortho position partially negative in charge. Hybrid structure of phenoxide ion. Phenoxide ion gets stable through formation of this hybrid structure, and as a result phenol acts as acid. Now let us see about the acetic acid. Acetic acid. In water it produces proton in this way: acetate ion, and proton. This oxygen hydrogen bond suffers heterolytic fission. In phenol, this oxygen hydrogen bond experiences heterolytic fission. In case of acetic acid, this hydrogen gets free as proton and acetate ion is formed. This acetate ion undergoes resonance structure. This electron moves here, this pi bonded electron moves here. Ultimately this hybrid structure is obtained: oxygen partially negative in charge, oxygen partially negative in charge. That is, here this negative charge gets dispersed between two oxygen atoms, and in this way acetate ion gets stable. That is, here we can write a hybrid structure of acetate ion. Oxygen is partially negative in charge. This oxygen is partially negative in charge. In acetate ion, negative charge is bonded to two highly electronegative oxygen atoms. Now, let us compare which one is a stronger acid, phenol, carbolic acid, or acetic acid. In phenoxide ion, negative charge is bonded to one highly electronegative oxygen atom and benzene ring. But in case of acetic acid, negative charge is bonded to two highly electronegative oxygen atoms. In acetate ion, negative charge is strongly bonded compared to phenoxide ion. That is why acetate ion has less tendency to combine with proton giving electrons. Less tendency because this is more stable. Compared to this one, it has a bit higher tendency because here negative charge is bonded to one highly electronegative oxygen atom and benzene ring. But in this case, negative charge is bonded to two electronegative atoms, highly electronegative oxygen atoms. So acetate ion is more stable than phenoxide ion. That means we can say that acetic acid is a stronger acid than carbolic acid. Now let us see differentiating reaction. Carbolic acid. We learned that this is weak acid and weak base, sodium carbonate or solution of sodium bicarbonate. Weak base. Sodium bicarbonate or sodium carbonate. Weak base, weak acid. Here no reaction, but acetic acid, which is a stronger acid compared to carbolic acid. Solution of sodium carbonate or sodium bicarbonate. As this is a stronger acid compared to phenol, it reacts with the salt solution, which is weakly basic, and as a result, this is formed sodium acetate, water, and effervescence of carbon dioxide gas. Carbon dioxide gas is formed with bubbles. Acetic acid can form carbon dioxide gas as bubbles. Phenol, carbolic acid, cannot form carbon dioxide gas. With this reaction, we can differentiate carbolic acid and acetic acid. Thank you very much.